In this in this session, we will briefly go over scientific notation. With the assumption that you've covered this in your math classes, this will be just a very quick review. A scientific notation is a way of representing either a very large number or a very small number in such a way that it's more easily understandable, more easily used in calculations. Scientific notations take the form of some number a times 10 raised to another number b, where we call the number a as coefficient and the number b is called the exponent or the power. The coefficient has to be a number between 1 and 10, but not including 10. Basically, what that means is that the number a, the coefficient, has to be one that has only one non-zero digit before the decimal point. Number b, that is the exponent or the power, can both be positive or negative. So for example, a number such as 8 times 10 raised to 5 is a correct scientific notation because it has one non-zero digit before the decimal point in the coefficient and has a power. In this case, the power or the exponent is positive. So is the number, let's say 5.20, a correct, times 10 raised to minus 6, a correct form of scientific notation for the same reason. However, if let's say we wrote a number such as 0.00320 times 10 raised to 6, is this a correct form of scientific notation? No, this isn't. The coefficient must have one and only one non-zero digit before the decimal point. So in such a case, we have to correct it. We have to rewrite this number in a standard form of scientific notation by moving the decimal point to the appropriate place. Now in this case, the correct position of the decimal point is after the first non-zero digit 3, so that the coefficient becomes 3.20 times 10 raised to, this time now the exponent, the power would change because we move the decimal point 3 places, so the exponent becomes 3. How about we had a number, let's say 750 times 10 raised to minus 6. Is this a correct form of scientific notation? Once again, no, this isn't correct. The decimal point must be after the first non-zero digit. So in this case, the decimal point needs to be moved to be after 7. So the coefficient becomes 7.5, and the exponential term, since it's a negative term and we moved to the left, becomes minus 4. So whenever you encounter scientific notations written incorrectly, you do have to rewrite them in the correct form such that the coefficient has one non-zero digit before the decimal point and then the appropriate power. Now let's complete this table, keeping in mind the process of going between decimal notation and scientific notation. One thing that I would like to, however, highlight, since we deal with measurements, this is important, that when you do convert between decimal notation and scientific notation, the total number of significant figures in the original number must be kept the same. In other words, whatever number of significant figures one starts with, the answer should have the same number of figs. As an example, in the first case, the first number has has 6 significant figures. So when you rewrite this number as a decimal form, the number should also still have 6 significant figures. So the coefficient would change to 6.35037 to have 6 significant figures, and then since the decimal point was moved 9 places to the left, would become 9. The second number has 4 significant figures. Please remember that a trailing 0 is significant if the number has a decimal point present. So our answer should also have 4 significant figures. So would this answer be correct? Therefore 5920. No, this is not correct because this number has only 3 significant figures. So you need to be very careful how you write the answer such that it has 4 significant figures. One of the ways to do that would be to put a decimal point after the 0 so that the trailing 0 then becomes significant, or you can also use over bars over the 0 to make it significant. Now, as I said before, the over bar is not used very commonly for this purpose. We use decimal places instead. So, but either of the approaches would be correct. Okay, so let's go ahead and complete the remaining very quickly. The trailing 0 in the next example is also significant because of the decimal point. So 3 significant figures, 0, and the power would be 1, 2, 3, 4, 5, 6, 7 minus 7. In this case, 1, 2, 3, 4, 3, 6, 5. Now the next one is a very large number, but please remember we have to keep the number of significant figures the same and move the decimal point 22 places. So we've already moved it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Phew. Just make sure that you do not put a decimal point at the end because then the number of significant figures would change. The last one is 1.6738 to have 4 significant figures with an exponent of 4 because a decimal point moved 4 places. Okay, another thing that's very important as far as scientific notations is concerned is how to handle scientific notations when you either multiply them together or divide them together or add or subtract them. The rules are, again, as a review, when you multiply scientific notations, the coefficients of the two are multiplied together and the exponential terms, the powers, are added together. When you divide scientific notations, the coefficient of the numerator is divided by the coefficient of the denominator, whereas the exponent of the denominator is subtracted from the exponent of the numerator. Addition and subtraction of scientific notations only works when the exponential terms are the same. If the exponents are not the same, then one of the scientific notation has to be changed in order to make the exponents the same, and then the coefficients can be added or subtracted as the case may be. Now, most of our examples will involve multiplication and or division of scientific notation. So those are the ones that we'll focus on for now. Addition and subtractions are not, of scientific notations, are not very commonly encountered, at least for our purposes. Okay, so here are some examples for us to try out. This may be a good time for you to stop the recording for a few minutes while you calculate all of these and write down the calculator answer. So assuming that you finished calculating these and written down the calculator answer, hopefully your answers and my answers match. But assuming that all of these numbers belong to measurements, the final answer has to be adjusted for significant figures in this case because we are multiplying and dividing only. So let's go ahead and together quickly round all of these answers to the correct number of significant figures. The first answer has to be rounded to 2 significant figures because of that. So it gets rounded to 1.7 times 10 raised to 9. The second one has to be rounded to 1 significant figure because of that, meaning that it gets rounded right there. 1 times 10 raised to minus 2. Next one should be rounded to 2 significant figures, becomes 1.6 times 10 raised to 14. Next one also to 2 significant figures, rounds up right there, becomes 7.4 times 10 raised to minus 16. Next one to 1 sig fig right there equals 8 times 10 raised to 23. Now the next one is rounded to 2 significant figures because of that, meaning that it needs to be rounded right there, but the first digit to be dropped is greater than 5, so the last digit to be retained should be raised by 1. But when you raise 9 by 1, it becomes 10, so the answer becomes 2.0 times 10 raised to 3. Now please understand that this is written as 2.0 in order to have two significant figures.